Hi there, welcome. And this time I'm going to do digits, FRQ. This FRQ is going to use array lists and it's going to be lots of fun. How we're going to divide up a whole number into its various digits. So we're going to use a few little formulas to do that. It shouldn't be too hard. I'm going to guess this won't take too long, but I better not be too confident. Let's jump in and see. So this is a publicly available FRQ, and it's, well, I'd say this is a little tricky. It can get confusing, but the more you've practiced working with numbers and using division and modulus, the easier it'll be. Okay, so the task of this, the goal of this is to process the digits of a non-negative integer. Okay. Process the digit of a non-negative integer, and we can show this below. We've got basically an array list, which is a digit list, right? It's integers. It's a digit list, so it's a list of digits. It should appear in the same order as they appear in the original number. So digits is the constructor here. It takes a number, and what we're meant to do in part A is to turn that into the digit list, or store them into this array list, one number by one number. So for example, if we get the number 15704, we're going to turn digit list into 15704. Okay, or if it's 0, we're just going to turn it into 0. Okay, so our job is to complete the constructor in part A, and then write the digits method slightly increasing, which returns true if digit list appears in slightly increasing order. Okay, so a list is considered strictly increasing if each element after the first is greater than but not equal to the preceding one, right? So 1356 is increasing, 1336 is not increasing, right? Okay, so that seems like, let's tackle A first, and what we're going to do is figure out how to divide up a number into its digits. So let's start with that and get to it. Okay, so split my window here and let's get some room. There we go. All right, so I've kind of started off with a few, just a basic outline here. So the point is that we're taking a number here and we have to turn this number into its pieces. Now, before we start, let's look at this from the point of view of, like, we're trying to store stuff in an array list, which is an integer array list. We need to go and initialize that array list. Before we do anything, we have to create that array list. Right now we've declared that we've got a variable which is going to point to an array list, but we need to go and really define that. So let's go ahead and say digit list equals new array list of integers. Okay. All right. And so now I've generated a constructor here. So now I've got actually something to put things in. From now I can go and add things to that list, but I first have to make it. Okay, how are we going to divide up this number? Well, if I have a number, let's say I have 34, and I divide this number by 10, what do I get as a result? Well, I'm going to get the number 3, right? 3.4 really, but if it's an integer, I'm just getting the 3. So that's a way that I've sort of separated the number off, right? And now what if I do 34 modulus 10? What am I getting? Well, it's going to divide evenly, right, 3 times, and then I'm going to have 4 remainder. So that's going to give me 4, and this is going to give me the 3. Okay, fair enough so far. It seems like I'm dividing up digits. However, the problem is that what if my number is like 340? even greater, 3401. So now, when I've divided by 10, I've got actually 340 and 0.1. I'm ignoring the 0.1. And here I've got 1. So 3401 and modulus 10. The remainder would be 1 after I divide by 10. So when I do the modulus, I'm always getting the last digit, but I'm trying to save it in the order that they're like from left to right. So what am I going to do? Well, if you know that with ArrayLists, there is a method of ArrayLists, we can use add. Now add will add something to the end of the ArrayList, but I also have, but we can also use add with some different inputs, right? And so not just the thing we want to add, but if we specify a number in here, for example, I can use it like this, index and value, right? So if I just give it one value here, I'm adding one value. But if I add two, right, two inputs here, I'm actually choosing the index and the value. And this is from the Java quick reference. You might be able to see it here. I'll just bring it across a little bit. So in the Java quick reference, you can see here that with our ArrayList, we have the add object here. We take an object, right? And this method takes an index and the object here. So this is the other way to use the add method. And what we're going to do is as we develop our remainder digits, we're going to use this method to put them at the start. And so we should we should take our remainders and keep putting them at the start until we end up basically with the thing in the right way, in the right thing. So let's move that back there and let's start to put this into process. So instead of this one, I'm going to use add index, right? And the index will be 0, right? So I'm going to use the 0 index and keep adding to the start of the array list. So if you think about this number like 3401, what I'm going to have is an empty list, and then I'm going to add the 1, right, to the start of the list, and then I'm going to add the 0 to the start of the list. Now I've got 0, 1, and then I'm going to add the 4, so now it's 4, 0, 1, and then I'm going to add the 3, and that will put it in the right order. Okay. Now, important, don't destroy num. Keep num as it is. Don't let it get destroyed. So what we're going to do here, and maybe I'll leave that up there just so you can see it. Let's comment it out. Okay, so that's the idea. Let's go ahead and implement that idea. All right, so we're going to take num. Okay, and this is now passed as a value. So what we're going to do is say, here's our number, right? So our number, let's just call it the remainder, right? So we'll have remainder, and then we'll have, so remainder, and then we're going to have the number at the start. So actually, no, let's call this digit, and let's call this remaining, or rem. Okay, so the remaining number we have at the start is num, equal to num. Okay, and as we go through the loop, we're going to process it one by one. So I think we're going to use a while loop because we won't really know how many loops we need to make. Right? We don't know exactly how many loops we'll be making, but we know that while rem is greater than 0, because once it gets to 0, we won't need to add any more. Right? So while rem is greater than 0, we're going to process this list, right? And we're going to get the division by 10. So digit equals rem mod 10. And then now we're going to change the remainder. So remainder, we're going to divide equal 10. So we're going to basically cut remainder down to the smaller version, right? Divide equal 10, right? Basically this is remainder equals remainder divided by 10. Okay. I guess we have digit and rem. And now we're going to go and say, let's add digit using our ArrayList terminology. So take our ArrayList, which is called digitList. We're going to use add, but add it at the start, at the 0 index, and we're going to add digit. And eventually, 3 is going to get divided by 10. So in this example, 3 is going to get divided by 10. It won't, I mean, the remainder is going to be 3. It's going to get saved. And then 3 is going to get divided by 10. It's going to leave 0 because 0.333 saved as an integer. Why does it lose the decimal place? Because ints have no way to save the decimal place. So when we're saving this digit and the remainder, these are integers. The decimal place gets dropped. Not rounded up or anything, but dropped. Okay, so, we added digit list, and that's the constructor. So I think we're done. Let's erase this portion here. We don't need that anymore. And we don't need that. And so I think we've added enough there. Okay, that's good. Alrighty, so now that's constructed. Now we need to do part B. Part B is strictly increasing. Okay, so this is a true-false method we're returning here. And we basically have a thing where we're going to be returning true if we get through this and they're all increasing. If not, if we find that it's not, we return false. So this is more like an if loop, a for loop, because we need to process our array list. And I'm going to suggest we just do this as a really simple for loop. So int I equals 0, I less than digit list dot size, I plus plus. So let's just process this and then say, now here's the thing, we're comparing the number to the next number. So actually we're comparing if we have a list, and let's draw the list up here. Okay, so I'm going to do an example list here. Let's say that's my digit list. I'm comparing 3 against 4, and then 4 against 5, and 5 against 7. So actually, either I'm getting, so here, if I'm getting, so I've got digit list dot get 0, and I'm comparing with digit list dot get 1, or am I saying I, right? Whatever I is. If I is 0, I plus 1. Now, when I get to the end of my digit list, I is going to be less than digit list dot size, which is the end of the list, but then plus 1 would have me go over the end of the list. So that's not going to go over well. We can't go over the end of the list. So I have to stop before the end if I'm comparing ahead, like that. So the I plus 1 will now be the end of the list. So I'm going to compare now. So basically, if I is greater than the next one or equal to, right? So this is my condition. If I find that is true, then I can return false. I know I found something that's not right, and then I can return false. If I get to the end of my loop, it means that everything's been fine so far, so I'll return true. And so now I can get rid of all that. And that should be the answer. Here the problem is, I mean, the trick is you're comparing two values in a list. You have to be careful of the boundary error, okay? So either you do it like this, where you're starting at 0, and if you're comparing to the next one, the I plus 1, then you're ending your loop 1 time early. You can do it another way. You can do it the reverse way, where you start at 1 and you compare against the previous one, I minus 1. You can do that as well. Just be careful of your boundary errors, that's all. Okay. And so that should do it. That's our digits. Okay, so I hope that was helpful. It seems to be, I think I've just hit the 20-minute mark, so that's about the timing you'd want for the exam. So yeah, there you go. Not too many lines of code, really just, you know, this was probably the longest one, and, you know, not really too many lines. So don't try writing too much. Like, if you're writing too many lines, you might have got a bit wrong. It's usually a simple thing that they're trying to ask you to do, 3 or 4 things that you need to do, and that's about it. Okay, see you next time.